Welcome. Solar cycle 25 is getting underway, and this is a status report of that cycle as of the end of September 2020. I hope you will enjoy. Let's first go over a summary of what we're going to talk about today. In the background here I have an image of the sun at solar minimum on the left and at solar maximum on the right, and we're so going to go over the next few years from that picture on the left to the picture on the right. And so the sun has just started on that journey in the last few months. However, the sun has been relatively quiet in September, though 11 regions did produce sunspots, and we did have a C flare. I've got videos from the month of September in a number of different wavelengths. I've got some information released by the NASA and NOAA Solar Cycle 25 Prediction Panel, and I'm going to compare the minimum between solar cycles 23 and 24, that's the last minimum, with the conditions in the current minimum between solar cycle 24 and solar cycle 25. If you had been tracking what the sun's been doing from various solar websites, for example the Solar Influences Data Center, they will claim that there was a large number of spotless days during the last month. In fact 27 according to the SIDC. So how come I found 11 regions on the sun in that same period? By the way, they were all solar cycle 25. There were no solar cycle 24 regions in the last 8 weeks. The thing is, we count them differently. I count any region that produces a sunspot, no matter for how big the sunspot is or how short a time it lasted. If the magnetic fields were strong enough to produce a sunspot, then they're counted as far as I'm concerned. They have certain criteria for how long the region has to last, what size the sunspot has to be, and so on. My sunspot groups don't meet those criteria. However, if you use my criteria, you can see in blue here on the right, we have a graph as a function of time that the number of solar cycle 24 regions has been steadily declining over the last 2 years. Now, it started off with a very low number of solar cycle 25 regions back in 2019, but after solar minimum the number of new cycle regions took off quite rapidly, and now solar cycle 25 regions dominate over solar cycle 24 by a factor of 10 to 1. Here are images of all of those spots. I've marked each one of them with circles because some of them are so small it's hard to see. And that's possibly the reason why some of these observatories did not pick up these particular regions, because they don't meet their criteria by being too small. The region that produced the C flare is this one here. You can see it's a somewhat larger spot than the other ones, even though it's near to the limb. The problem with these is that the life of these regions is relatively short, and so until we get larger regions that last longer, we're not going to get a major surge of activity. Well, let's start by looking at some movies. We're going to start with the SOHO magnetogram movie. Remember, 1 second is approximately equal to 1 day. If you want to be able to tell from the magnetogram which solar cycle these regions come from, in the northern hemisphere, solar cycle 25 regions start with white polarity leading, like the large region you can see in the upper right. In the southern hemisphere it's the reverse way round, and you can see there's a small region that is obviously solar cycle 25 just below the V of the south. Of course, solar cycle 24 is the exact reverse. Next we'll take a look at helium-2 movies. This is plasma at about 50,000 degrees. This is actually relatively cool material compared with the rest of the corona, so it's interesting from that point of view. However, the things to really look at here are the bright areas above the limb. These are called prominences. When they get onto the disk, they become dark and are called filaments. They're the same thing, just different names depending where they are on the sun. However, these things can erupt. And as you'll see in the CORONAGRAPH movie, we'll see some evidence of these things erupting over this period of time. So enjoy. Next, we'll take a look at the corona. This is material of over 1 million degrees Kelvin. The bright areas are what are called active regions, and they're usually associated with sunspot groups. The really dark areas are coronal holes. That's where the coronal fields are open and the high-speed solar wind flows out towards the Earth. But the thing to notice is that even the areas that we call quiet sun are really relatively active. You'll see changes all the way through as the sun rotates. Next, we'll take a look at the high corona, and for that we need to go to the SOHO spacecraft, not the Solar Dynamics Observatory, and use the coronagraph there, the LASCO instrument. This is the C2 field of view, the smaller of the two fields of view, and the picture, the black circle in the middle is the occulting disk, and in the center is the size of the sun on this sort of scale. Now what you're looking for here is activity in those two bright areas, one above the left hand side and one above the right hand side of the occulting disk. And what we will be seeing are various events like large bubbles exploding away from the sun. Those are coronal mass ejections, and they can cause geomagnetic storms on the Earth if they're directed towards the Earth. And that particularly happens when it's on the west side of the sun, the right hand side of the sun. So keep an eye out for that. I mentioned earlier that we had a C flare from one of the regions, and it's this region here. This is a movie taken in Iron 20 from the Solar Dynamics Observatory AIA instrument, and that's equivalent temperature about 10 million degrees. Now you can see other structures here when there is no flare going on, because the line is contaminated with some cooler material, about 500,000 degree material. So you can see the general structure of the sun, and then what you'll see is a brightening in the region itself. Now I predicted this flare about 5 or 6 days before it actually occurred, and if you want to see the latest updates on the what's going on the sun and any predictions I might make, you can see my Twitter channel, DRK Strong. The NOAA-NASA Solar Cycle Prediction Panel has reported that we're now officially past minimum. They put minimum in December of 2019. Now I would put it a couple of months earlier than that, but that's their opinion. They're also maintaining that Solar Cycle 25 will be larger or about the same size as Solar Cycle 24. Not, as some people are reporting, much smaller than Solar Cycle 24. So this does not look good for those people that are predicting a grand solar minimum. One of the arguments that's most commonly put forward for the fact that there's going to be a grand solar minimum is that this current minimum is much lower than the previous minimum. Now let's put a pin in that particular argument once and for all. Here I've got the total solar radiance for the last 17 years. Back in 2008-2009, you can see the total solar radiance was at about 1361.4. I've drawn a blue dashed line for where the current minimum is, and that's higher, as you can see. So that would say that our current minimum was much more active. Another way of comparing the two cycles is to see what the flare situation was between the two minima. Here on the left we have the transition from solar cycle 23 to solar cycle 24. Up to solar minimum, which was in December of 2008, we had 7 old cycle flares and 2 new cycle flares, and it was mixed with 1 M flare and 8 C flares. Now the old cycle is marked in blue, the new cycle is marked in orange. However, after the minimum we had 0 old cycle flares and 3 new cycle flares, all of which were C flares, and that would be up to September the 30th, just like we have data for now. But now let's take a look at what the situation is for the transition from solar cycle 24 to solar cycle 25. Now let's take a look at the transition from solar cycle 24 to solar cycle 25. Up to minimum we had 29 old cycle flares and 0 new cycle flares. None of those were M flares, so all of the 29 were C flares, and they were from 3 particular regions, I seem to remember. After solar minimum, in December of 2019, we had 0 old cycle flares and 6 new cycle flares, 1 M and 5 Cs through to the same date. So you can see we've been much more active in this cycle, although still nonetheless solar activity has been low, but we've been much more active since the transition to solar cycle 25 is occurring compared with the transition from 23 to 24. So again, we would argue that this current transition is more active than the last one. Now we shouldn't get too heady about this new cycle as yet because it's still relatively quiet. This is the sunspot number from the Solar Influences Data Center in Belgium. The yellow is the daily numbers, the blue is the monthly numbers, and the red is the smooth numbers. And you can see the most recent data is still following the quieter of the two models. Now that could change very easily, but at the moment that's what the data is telling us. So it doesn't mean that we're going to get a rip-roaring huge cycle. It means we're probably going to get a relatively modest cycle, perhaps just a little larger than solar cycle 24. So what can we conclude from all of this? The solar cycle 25 sunspot regions are still small, weak and short-lived. Until they get larger and stronger and longer lived, we're not going to really be getting into the onset phase of solar cycle 25. But solar cycle 25 has already taken control. In 2019, 66% of the regions were from solar cycle 24 and only 34% from solar cycle 25. That trend has reversed quite dramatically in 2020. We've had 16% solar cycle 24 regions, but 84% solar cycle 25 region. And there's been an overall increase in activity of about 60% compared with last year. And that's so far. We have had no sunspots from solar cycle 24 for nearly 2 months. That I think is telling us something. And what it's telling me is the grand solar minimum is looking increasingly unlikely, and is about as likely as having a record high sunspot cycle this time around. So until next time, stay safe and goodbye.